Hello, wonderful people of the internet. Welcome back to another episode of Leos Labs. Okay, so there's a lot to catch up on. Emrys and anyone who might be lurking in chat, hey, thanks for being here. Let's go ahead and get started. We've only got about 2.5 hours of stream today. I'll explain that in just a second. And yeah, I think we can actually get a lot done if we just focus, put all of our minds together and try to get something done. Also, let me move over just a little bit. I think I'm out of frame. Okay, I'll move this over there, that over there. Okay, I don't know where to start here. Hey, Henry, how are you? But I guess we'll start with just the 2.5 hour stream. Long story short, we had some paperwork to do this morning. We got in at about 2 o'clock in the afternoon, 2 to 2:30, something like this. Then we had lunch, we did some more paperwork, and then I just took about 30 minutes to just kind of like situate myself again, and then I started to stream. That happened to be at 3:30 p.m. That's just how things happened. Also, because it's Tuesday, my wife and I always have at least one meal together for dinner, and that's Taco Tuesday. So at 6, I will have to leave. So that's in 2.5 hours from now. This means I'm not going to be doing the Swoleos workout today. It's specifically going to be just a 2.5 hour stream talking about my newfound passion in life, which is histograms. Wow, amazing. Okay, let me talk about something. So yesterday we had like almost an hour, maybe even more than an hour, talking about YouTube and how it fits into the overall ecosystem and what the point is of YouTube, blah, blah, blah. Look, the truth is I bike shed about this so much. I don't even know what the term bike shedding means, but I use it. I do it all the time when it comes to YouTube. The fact of the matter is that, in my opinion, I should just be making cool content, right? And so what I did initially is I was like, okay, make cool content. What is a really cool way to show people what fractal compression is like? And I was like, becoming a fractal. There we go. That's a super cool thing to do. Let's make the world's first full, high definition, 60 frame per second video done entirely via fractal compression. That would be really cool. Then I realized, okay, well, to do that, we need, fractal decompression, blah, blah, blah. So we need, fractal generation. So then it's like, okay, that's still fine. The world's fastest fractal generator is still fine. But to do that, we need histograms. And as you've seen, for the past 3 weeks, I've just been banging my head against problem after problem. Every single time I've tried to move anywhere with anything, really. I've just hit my head against kernel abstractions or something, right? And so I finally just said, screw it. Here's what I'm going to do. If the point of my YouTube channel is to show people what research is like and why this is interesting, even though it doesn't seem interesting to many people, why not just start with histograms? Why not just make a video and also make a package in Julia and write a Journal of Open Source Software paper on a similar topic about parallel histograms, why it's actually a very difficult problem, a deceptively difficult problem that, most people, it's actually very intuitive. It's very understandable. It's very clear as to why it's a difficult problem as well. So it's one of those things that I think if I'm going to try to sell research, might as well start here. We're eventually going to get here, and there's a whole bunch of other things I want to do to get here. But the fact is, if I wait until we get to this point to make videos, I'm going to make like 2 or 3 videos a year, and that's just not going to cut it, right? So I want something that I can put out every month, and I realize histograms, fractal generations, becoming fractal, this is all stuff I can do within 4 weeks of each other, because this guy, I think, is within 3 months from being done. So where does that leave us? Why is this interesting? Well, let's start. Where do we want to start? Actually, does anybody have an idea of where we want to start? So yesterday we had a bug with kernel abstractions that I took a step back and I fixed. I found out what the problem was I didn't fix. So yeah, let's start there. Let's start with kernel abstractions then. All right, here's the thing. For the past n weeks, where n is higher than 3 and I don't know what the number actually is, I've been really struggling with a particular package in Julia called kernel abstractions. Now, this particular package is incredibly useful. It's super nice. What it does is it allows for you to write code that executes on the CPU and also the GPU, right? However, in allowing for you to write a single piece of code that executes on either or, there are some caveats here. The big benefit is that you no longer have to write 2, 3, 4 functions for each architecture you're dispatching on. The big caveat, the big downside is that sometimes this one function fits all type of scheme fails a bit. So the first failure we saw was the usage of shared memory. About 2 weeks ago, we tried to use shared memory and it was just broken. So we did a quick fix and fixed that in kernel abstractions. The next thing we ran into was the int32 conversion. Essentially, we were unable to convert anything to an int32 value in a kernel abstractions kernel. Hey, Cosmic, how are you? And then the next thing we ran into was a bug that I honestly still don't fully understand, but it has to do with synchronization in loops / conditions, specifically on the CPU. I'm fine. Ordinal markup is kind of boring, though. Yeah, you were mentioning that during the last time you were here as well. I'm surprised you're still going on with it, honestly. So we're going to talk about what this bug is. Let's do it now. Let's talk about the bug first, and then we're going to talk about histograms next, and why I actually think there's a lot there that a lot of people might not have. Thought about before. So let's talk about the bug. This is obviously ASCII Aquarium. Let's Control C. I'm fueled purely with masochism and dedication. So here's the thing. The word masochism, and I'm not stopping, right? I never knew. So I always thought that was someone who liked pain. I never knew until I've been using the word, not fairly frequently, but frequently enough in my vocabulary for like 4 or 5 years until someone told me that apparently masochism is like some part of some sexual thing. I had no idea. And so like when I was saying, yeah, I'm a bit of a masochist, because that's what you say. It's like, yeah, I'm a bit of a masochist here. I apparently really like pain, and that's why I'm a physicist. You say that kind of stuff, right? I had no idea that there was a sexual connotation to that at all. And apparently I was the weird one for saying that kind of stuff. I just didn't know. I'm not saying that, like, for me, when you say masochist, I know exactly what you mean. It's like, you obviously mean that, you just like pain and that kind of stuff. But yeah, some people apparently think it's specifically sexual. And so some people will, radically misinterpret what you're trying to say. S&M whips. Yeah, I don't know what the S stands for, but I don't care. Like, who cares, right? But M is probably masochist, right? So S must be someone who likes pain, sad person. Sadism, I was close. Okay, so what am I going to do next? I'm going to go to kernel abstractions. Let's just go over here. Kernel. I'm on Japanese mode. That's the problem. Over here, and then we're going to do kernel abstractions here. Sadism, or is it sadism, is more of enjoyment inflicting pain. Masochism is receiving it. That's fair. I'm sorry that we started talking about this. I don't know why it came up. I don't know why I brought it up, is what I should say. All right. Let's go to issues, and let's open up the issue. Okay. So after stream yesterday, I mentioned it on stream. I explained it. I was a bit down because I had spent so long focusing on these just small issues that kept coming up with kernel abstractions and histogramming and just so many issues, just so many freaking issues that I didn't need to deal with, right? And because I was so hyper-focused on getting that big Becoming a Fractal video out, basically, every single thing I was doing was a distraction, right? So the 2 weeks that I spent just getting kernel abstractions working for the histogram methods and stuff was just a waste of time. That was a waste of 2 weeks when I'm kind of on a deadline to get the video out as soon as possible. But, now if, again, I think about making a video for specifically histograms, all of a sudden this is no longer the case. So after stream yesterday, again, I was kind of down, but I spent some time creating a minimum working example. Here is that minimum working example of the bug that we were encountering yesterday. So using test, using CUDA kernels, flash abstractions, blah, blah, blah. We create a function. In here, we create a thread ID, which is at index global linear. We do at uniform n. So again, a uniform is an object that basically continues after a synchronized statement. It's specifically a GPU or a CPU call. We create another at uniform a, and then we say if TID is less than n, we say for I is equal to 1 to n, a is plus equal to 1, and then we do at synchronize here. So what happened was the at synchronize basically made it so There was some weird loop stuff that I'm going to show you in a second, but basically made it so we could no longer find TID. And I'm going to show you exactly that bug in action. So we're going to CD into projects, simuleos and histograms. Over here, we're going to do CD projects, simuleos and histograms, ls. Okay, actually, I'm here to recommend a really decent incremental game being called Synergism, a great balancing, great design, completely original. Interesting. I think, maybe Gibbous would be interested in that. You also can play incremental mass, which was inspired by antimatter dimensions and synergism, but has several time walls. So, okay, fair. Okay, so let's just go over here and let's open VI minimum working example 323.jl. Yes. This is the issue. I'm going to modify this so it says B instead of A just because, I don't know, I'm just going to, that way people aren't confusing A as the array and A as the variable. That was my bad. I should not have done that, but I was dumb. So let's do Julia. And we're just going to include minimum working example 3.jl. I've got a lot of minimum working examples. While has an A. Thank you for that. This is, all right, let's go ahead and control C on that one because that one's going to break. Hey, Fortuitous Lover, how are you? All right, we're going to do right over here, include minimum working example 3. Whale. I sounded like a southerner trying to explain what, like, there's a particular accent that I never got when I was in the South, and it's like instead of saying welcome back, you're like welcome back, this type of thing. Okay, what is going on? Where's input? Right. Okay, let's set this to be 10. I realize now the issue. I think actually minimum working example 4 was one I was using. Yes, it was minimum working example 4. Okay, let's do 4 instead of 3. Okay, give this a second. It's going to break as well. Luckily, we're not doing push-ups today, so I can create as many errors as I want, and there's going to be no repercussions. Oh, hey, there was one other thing I wanted to talk about that I completely forgot about, and right, let's go ahead and do it. One day I'll understand what Laos is doing. Oh man, I don't even understand what I'm doing. Input. Oh, what? Is this 4? Wait. I'm just dumb, is what I am. I'm just gonna say n is equal to 10. Man, I don't know what was going on with that minimum working example. Let me edit the one that's on GitHub as well, because I don't even know how that one ran. And write this, go over here. We're gonna run it one more time. Control CD, Julia, include. Howdy cowboy. Yeah, I mean, look, I grew up in Alabama, right? So I should have at least reasonable Alabamian accent, but I don't. Like, my accent's just like, it's weird. And I think that's because I didn't have any friends growing up. I have nowhere to take that statement. I have nowhere to take that statement. Also, what is happening? 1 second. Oh, no. Okay. Dang. So uniform n equals n. Is this what I want? Come on, just give me something that works. Let's see. CUDA Ilya instruction encountered. Okay, Control D, Julia. That was an error message. Let's see what this one does. But yeah, again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know. I wish I knew where I was going with that comment before. Anyway, I'm just going to recreate this bug, and then I'm going to fix the kernel abstractions issue. Yes, this is a bug, TID not defined. So let me just update the kernel abstractions issue so it actually has the correct kernel inside of it. So we're going to edit this guy, and we're just going to paste the kernel right there. Should be fine. Test kernel A. Where is it? Oh, there it is. So we're going to do this, enter, and then we should have one kernel and the other kernel here. Move down here really quick. there should work. And I believe that's the actual file that I'm working with now. So let's update the comment. Sure, fine. Okay. So what's going on here? Wow, I have no idea. I don't know why I talk like that sometimes. I'm so sorry. Anyway, the point is the following. We have the kernel function f test kernel, right? So what this does is it first runs it on the GPU, then it runs it on the CPU. And what we're seeing here is that the GPU one is actually running perfectly fine, which is unusual. Usually with kernel abstractions, you run it on the CPU first because the CPU is more likely to pass. But I think because I'm more used to GPU architecture, I tend to have more problems with the CPU than I do with the GPU. Anyway, point is, we have at uniform n is equal to 100, so just n is equal to 100 is how you read that. B is equal to 0, and we say for I is equal to 1 to 10. If TID is less than n, we're going to say b plus equals 1 at synchronize and end. Now, it doesn't matter if these loops are mixed. It really doesn't matter at all. I don't know what I'm doing here. I'm just doing something with b in here. I don't know why I'm even doing that. But the point is the following. When we do this, we get error undefined variable error TID not defined. Now, what is TID? TID is the thread that we're working on, and for some reason, this if TID is less than n is failing, right? And I can show you exactly why in just a second. Is this your first open research stream? No, I've been doing a few open research streams actually recently. So for the past few weeks, honestly, I've been doing pretty much exclusively open research streams. I will probably not be doing a 24-hour stream, at least not anytime soon, because my stream stamina, like how long I can maintain a stream for, kind of dies at like 3 hours. I'm so tired after 3 hours. And yeah, I've added in the Swole Laos workout routine so I can extend that a bit. But quite frankly, like at that mark, like doing programming for 3 hours straight, I get quite tired. So long story short, I'm going to modify this one more time. So this is now length of A. That'll do. And let's do this one more time, include. I'm going to show you guys where this error is coming from in just a second. I'm just going to modify this comment one more time. Add it here, all the way up here, and we're just going to say length of A. Sure, that'll do. Update comment. Sorry. Do you miss Okinawa? Oh man, yeah, I definitely miss Okinawa. I mean, I don't want to be super sappy about this, but like when I think of places that I consider to be home, I never really felt at home in Alabama. I don't know why. I mean, don't get me wrong. I like Alabama. I miss my old hometown a bit. But there's certain things about it that I miss. Like I miss lifeguarding at the pools over the summer. That was super fun, super enjoyable. Teaching kids to swim was really fun. But I don't miss school. There's so many things I don't miss. And the culture there just wasn't nice. I don't miss that at all. At Auburn University, my undergraduate, man, I was so that whole time was just a blur because I was working so hard. I did essentially 3 majors in one. And then I was doing research with 3 different labs, and I was teaching classes, and I was doing so much work that I was getting like 4 hours of sleep a night on a good night. Like I was not healthy during my undergraduate. And so I don't really consider anywhere in Alabama like a place that, I feel like is home, But Okinawa was probably the first place I ever lived where I'm like, man, this feels right. Like I like being here, And so asking if I miss Okinawa is like, yeah, of course I miss Okinawa. That's like, of all places I've ever lived, that's the one place that I'm like, man, that's a place I really do want to go back to. Is this the most CUDA stream of the whole Twitch planet? There might be other people doing CUDA, but I'm actually not doing too much CUDA. I'm doing kernel abstractions, right? I thought you were in Cambridge, Massachusetts. No. So actually right now I'm in Barcelona, Spain. I just moved from Boston to Barcelona a few weeks ago. Actually, maybe 2 months ago now. But really, we've only been in this apartment for 1 month. So I haven't really been able to stream except for this past month. And so I'm slowly but surely ramping the stream times up so that I want to get to kind of like full-time stream hours, like 40 hours of streaming a week by the end of this month. So I'm kind of ramping up to that. World Traveler. Yeah, we were actually just talking about that today. So we had to get the thing we had to do this morning was we had to get like the it's called a TA. It's a special card to let people know that we're basically citizens, not citizens, but we're living in Barcelona, right? And when we were going there, I actually looked at my passport and I realized that I only have 2 pages on my passport. Well, you could 2 or 4, depending on how you count, 2 front and back pages that don't have stamps on them. And so like I'm not saying that I've traveled a lot, but I'm saying I've probably traveled more than a lot of people, This is definitely the most Julia stream of the whole Twitch planet. I don't know if that's true either. I know there's a bunch of other Julia streamers. Anyway, let's go over here. What I'm going to do is I'm going to run a comment here, which is called macro expand. And I'm just going to basically put this kernel right here. Bam. Okay, so what I just did, oh no, you kidding. Let me try running that one more time. Macro expand. Okay, let me try that again. I'm going to figure out how, we're going to figure this out. I'm going to move this down a bit. We're going to run macro expand, and then I'm going to make this huge. That is ugly. Okay. It's super ugly. Okay, let's try it again. I wish programmers would stick to the 80 column rule. Come on, guys. Like, it's not that hard. Anyway, let me do macro expand, and what I might do is I might actually just output this to file so we can look at it separately. So we're going to do this, and let me just run at macro expand here. And then we can show you exactly what's happening and where this error comes from. I'm going to comment these out for now. Screw it, I'm going to do it this way. Okay, now we're going to run Julia, minimum working example 4.jl, and we're just going to say file.txt. Oh, that already exists. So we're going to call it macro expand.txt. And you guys thought I wasn't good at naming. I'm not, though. Okay, so let's go into vi macro expand.txt, and of course nothing's in there. I for some reason I thought it would output. I was just trying to find a way to show this comment out. Okay, whatever, screw it. It's fine. It's fine. I'm just gonna show it here, and you guys are gonna have to deal with it. Oh, I hate this so much though. Okay, let's full screen that. Scroll up. Eesh. Okay, open up Julia. Now we're gonna run at macro expand this guy. Right, using kernel abstractions. At macro expand this guy. And then hopefully this gives us the appropriate macro. This should give us GPU test kernel, and then we have CPU test kernel up here. So function CPU test kernel. So this is what's being run on the CPU. And remember, the error is only on the CPU. The GPU is actually running okay. So what's actually happening here? So we say for I is equal to 1 to 10. If TID is less than n, again, that's exactly what we saw over here. We then see that the definition of TID here is actually within the loop itself. So what it's doing is it's taking our kernel definition of TID and it's moving this guy into the loop down here. And the reason it's doing that is for scoping issues, so that the value of TID is available within the loop at all times. But because of that scoping issue, it means that if we @synchronize, it will actually end the loop prematurely, or it's not ending loop. Basically, the condition up here will no longer be aware of TID because it's defined within this structure down here. So basically, we have to find a way to get around the conditional here. That's the issue. Luckily, we actually don't need this conditional at all in our case. Now, look, truth be told, I would love an elegant solution to this. I feel to some extent, maybe we should dig into kernel abstractions and create a fix for this. But on the other hand, the fix for this is already in kernel abstractions in that this if statement is actually redundant. So when you're working with CUDA, you're working with probably OpenCL as well. They work with this concept of blocks and threads instead of working with work groups and work items. The big difference here is that if you grab journal new page before, let's say 1,000 items that you want to work through, so a 1,000 item array, and you grab blocks of 256 threads, well, 256 times 4, right, will give you 1,024. So what this means is you're actually going to be grabbing 24 extra threads. And so this, if TID is less than n, is essentially me trying to correct for the fact that we could accidentally be grabbing threads in a block that don't exist in the array. However, kernel abstractions already deals with this under the hood because it works with a different structure altogether. So because of that, our solution is just going to be to remove that if statement entirely, and everything should work just fine. Look, it's not an elegant solution, but for all the purposes that we're going to run into on stream, it's going to be fine. So I guess we're okay, you know? Anyway, I have a real analysis exam tomorrow. I've got to go study for that. See you tomorrow. See you, Fortuitous Lover. Thanks for stopping by. Yeah, so that's kind of what the error was yesterday, what we ran into. I spent maybe an hour or two creating this minimum working example. It took a while because I didn't realize it was the @synchronize that was breaking everything. Again, essentially what's happening here is that kernel abstractions for the CPU will take this thread ID definition and move it into the loop that is created by the @synchronize. Just because, again, it's basically taking code and executes it on both CPU and GPU. So even though this is perfectly valid GPU code, it's invalid CPU code. I created the issue. I'm probably not going to fix the issue. I just wanted to create it. The reason I don't want to delve too deep into this is because I'm not sure when this is going to happen, but I know that the kernel abstractions developer, one of my best friends, has spoken a lot about changing the underlying infrastructure of kernel abstractions drastically. And when and if that happens, stuff like this will be fixed. So I'm not too worried about digging too much deeper into this. Okay, now before going into the histograms and why they're so cool and why I think there's a whole bunch of really interesting things to talk about with histograms, blah, 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 let's go on to one other topic. Gosh, I just can't. I'm sorry. I'm trying. I really genuinely am trying, guys. Please. Okay, twitch.tv. Okay, something happened. I don't know if this happened yesterday. In fact, I think it did happen yesterday. Let's go to browse. No. Let me go to my stream. Let me click on science and technology. Here. Okay, so something big happened yesterday, or maybe 2 days ago. I'm not exactly sure when, but essentially, if you look at science technology right now, you'll notice a distinct lack of ducks. That is really important. You mean that clip where you were too hot? Cowabunga, look, I mean, it sounds like people are really, really wanting me to open like an OnlyFans or something. And I got to say, like, give me a month. I need to work out a little bit, but at some point I wouldn't mind if people are into it. Anyway, my point is the following. There are no duck streams anymore on Science and Tech, which is super interesting. There's still a few people lingering about, but essentially they created a new animal category. So if we look for animals, what is it called? It's Animal Stream. What is it called? What's the channel called? 1 second. It is called General. Oh, I'm sorry. I didn't give you guys. Animals, Aquariums, and Zoos. Animals, Aquariums, and Zoos. Surely I can find it if I Google it exactly, right? Here, this guy. Now, what's interesting about this is actually, this has 21.6K viewers. Meanwhile, Science and Tech, let's just go back a couple tabs here, has how many? Let's just check. 1.1K viewers. So this is something I was thinking about the other day. So on the one hand, Science and Tech no longer has game development streamers because all the game development streamers are now in software and game development. It no longer has the animal streams because they went to their own channel, right? So now Science and Tech is left to be exactly what Science and Tech should be, which is Science and Tech streams. Like live earthquakes, I actually never had a problem with live earthquakes. I thought this was kind of nice. It's good to have a stream like that, I think. However, What this means is the science and tech category is officially just effectively gutted right now. Like there are very few people that are actually on this channel or on this stream right now. So this is good news and bad news. The good news is now there are fewer people streaming on science and tech. So if you are a scientist, if you are a tech person, if you do research, any of that kind of stuff, this now I feel is the perfect hub for people who want to do something, technologically interesting on stream. It's actually quite nice for that. However, the problem with gutting a category is that people don't know that this change has happened, right? So people who used to go to science and tech and then realized, actually, science and tech isn't what I thought it would be, and left science and tech still have a bad connotation with science and tech. So this was part of the reason why yesterday I announced that I want to start moving on to kind of more full-time stream hours. That is to say 40 hours of streaming a week live here. In the science and tech category, because now it's the perfect time to revitalize the category and just bring people back in. And so, it's kind of this weird mixed bag of, I don't know if this is good, I don't know if this is bad, but I think this is the perfect time to shake things up. And that's kind of how I feel. So we'll see how this goes. Again, I really don't know. I really don't know what the ideal future is for science and tech. But I would love to see more researchers. And on that note, let me very quickly post something in chat. So the other day, I think I can post this here. The other day, I created this research tag, user voiced thing. Now, look, because science and tech is now effectively gutted, I think actually just streaming the science and tech category is good enough. But I think having a research tag for people to browse with, I think would be quite nice as well. Again, I kind of feel like it's redundant now that we can just use science and tech. But I did want to put this out in case people are also interested in having another way to find people who are doing some sort of research on stream. I thought this tag could be useful for that. Okay. That's all the updates, everything we have to do. We talked about the kernel abstractions bug from yesterday. Now let's talk about histograms. Wow, amazing. I'm sorry, guys. Sometimes I act like overexcited about things that I shouldn't be overexcited about, but I am kind of excited about. So it's like, like that feigning interest in something. I only feign interest in things that I have an actual interest in. I don't know what happened to me as a kid, but I always pretend to be underexcited about things that I'm actually overexcited about. And so for me being like, wow, amazing. Like people clearly know I'm being sarcastic, but I'm not actually being that sarcastic. This is actually quite cool. And going back to the discussion from yesterday about what to do with YouTube and stuff, it's like, look, this type of stuff is stuff that I find really interesting. And if I only make my YouTube channel filled with things that I think other people are going to find interesting, it's going to feel hollow. So let's just talk about things that I find interesting and also talk about things that other people could find interesting as well. Histograms. All right, let's do it. Let me start by saying that we're over-optimizing the living daylight out of this problem. You might be wondering, why are we doing this? Isn't premature optimization the root of all evil? That is true. But I've said it before and I'll say it again. Premature optimization is also the root of good video content, at least in my opinion. I really like when people over-engineer things. So what is a histogram? Wow, I'm being super dumb today. Let's start by explaining what that is. We're going to have a string of numbers. No, stop it. We're going to have a string of numbers, which I guess I'll keep here in white here. So here's our string of numbers. I'm just pressing buttons. It doesn't really matter. Right. And we have the obvious question, which is, how many ones, how many twos, how many threes do we have in this list, right? So I'm going to write that question down because that's actually really important. Are in this list. Cosmic, my internet is so bad, I watch Laos in 160p. That's fair. It's close to 160p for me with 30-second latency. Oh man, I'm so sorry. I can't fix it. I can do nothing about that. I'm so sorry. I just hope you guys get better. It's like you're sick. Anyway, how many ones are in the list? That's the question. So there's actually a bunch of different ways to solve this question, but there's a bunch of other questions that we can ask as well. So this is one question I just wanted to keep down. Let's go ahead and talk about a solution to this question. So what you can do is you can create a histogram where we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Oh, well, let's just use 0 at the end there. Very low res gang. Well, I mean, look, at least Twitch is giving me quality options, right? Like, there have been several streams where Twitch just doesn't give me quality options, in which case it's impossible to view. I mean, that's actually... I have a relatively low resolution monitor right now. It is a rand-r. It is outputs 1600 by 900. Usually people do 1920 by 1080, but I'm actually doing 1600 by 900 because it means we get a higher quality with a lower bitrate. So that's like I'm doing the best I can, and my bitrate's only at 2K, so it's actually not high on that side. On the plus side, there are cats around me. Wait. That's from our side, so you definitely can't do anything. What if I use mobile internet for PC? I've done that before as well. Anyway, so, right. Let's say we're trying to create a histogram. What we can do is move this string of numbers down here, move this guy up here. As a question we save for later, move it up here. Okay. So what we can do is we can go through this list. And basically, if we see a 6, we throw that into the 6 bin. Bam. If we see a 5, we throw it into the 5 bin. If we see a 7, into the 7 bin. 3, we put it into the 3 bin, so on and so forth. This act of throwing numbers into bins is also called binning, which is why a lot of times if you hear people talking about histogramming, they might also be talking about binning. It's kind of the same problem. Right. So what you'll end up with in the end is kind of a bar graph. So you have this many 1s, this many 2s, this many 3s, this many 4s. I don't know the actual numbers, but you guys have seen bar graphs before, right? 7s, 8s. Pretend these are straight, and then, I don't know, a bunch of zeros. It doesn't matter. Point is, you get one of these guys, and this is called a histogram. It's the number of entries of a particular type of data within a data set, right? Now, this is super interesting for a number of different reasons. For example, we wanted to talk about creating the fractal flame method. And in the creation of the fractal flame method, you basically have a whole bunch of points in space. And what ends up happening is you'll have like 3 or 4 points all on the same pixel, right? So you have to say, okay, this pixel has 5 in it. This pixel has 2 dots in it. This pixel has 3 dots in it. 10 seconds in, working on max resolution. I mean, honestly, like, again, my bitrate's 2K, so I've got a feeling that most people can probably watch, is it 2.5K? Maybe it's 2.5K, but my bitrate's not particularly high. I'm using a low resolution monitor so that it's better to view on lower bit rates. So I think probably you could watch it on mobile, just anywhere without too much trouble, but maybe not. Maybe I should lower the bit rate a bit more. Anyway, right. So this is interesting for a number of different reasons. There's actually a bunch of different reasons why this is interesting. But what I'm interested in is talking about this in parallel. Okay, so what is the fundamental issue here? There's actually a number of fundamental issues with putting this in parallel. Okay, so, right, let's say we want to do this in parallel. The easiest way to think about this is to split this up into 2 different cores, all acting simultaneously, right? So you have, one core doing 6, 5, 7, 3, so it put 1 and 6, 5, 7, and 3, and you have another core doing 3, 4, 5, 7, right? So you have another 3, 4, 5, 7. Now, the key problem here comes from when both cores have to write to the same location in memory at the same time. So for example, this guy could be trying to write to, I don't know, this 0, while this guy's also trying to write to 0. So because they're both trying to write to the same 0 at the same time, they're both basically doing the operation of, let's say A of I is going to be equal to A of I plus 1. And because they're both doing the same operation, they're both reading the same A of I, and they're both setting it equal to A of I plus 1, meaning that they're both basically only incrementing by 1 when it should be incrementing by 2, right? Because you have 2 writing in the same location in memory. So this issue of basically creating a a histogram in parallel goes beyond this, but this is the core like problem that I usually talk about. Which means if you're going to have to do something in parallel with multiple cores, you're going to have to find a way to serialize this process, or find a way to basically create the histogram in a way that mimics a serialized method, right? So you could, for example, have multiple copies of the histogram and different things like this. There's also another bunch of issues here that aren't as obvious. So again, let's take this list of numbers that we have over here. Let me just go up here 1 second. So we have this list of numbers, right? Well, let's just think about what we're doing here. We're taking the 6 and we're putting it into the 6 bin. We're taking the 5, we're putting it into the 5 bin. We're taking the 7, putting it into the 7 bin, right? So what we're doing here is we're taking a bunch of data and reading it in a coalesced fashion. That means one after another, 1, 2, 3, 4, 5, 6. But we're writing it in a very non-coalesced way. By that I mean it's essentially random. So we go from 1, 2, 3, 4, 5, 6, as in reading one element after another, into something that's very non-coalesced. So it means that, instead of going 1, 2, 3, 4, 5, it goes like 4, 1, 7, 6, 2. And this means that even though we're able to read from this data array very efficiently, we cannot write to this histogram very efficiently, which is why for most parallel processes, for most applications of this on the GPU, we make use of something called shared memory, which is essentially a small memory resource that is available only to the threads in a block that allow for us to more easily do non-coalesced memory transfer, right? And then after we've done that, we can then do a coalesced read out, a coalesced write onto the actual histogram, right? So what we're doing is we're creating a bunch of mini histograms that can then be transferred one-to-one onto the actual overall histogram at the end. And this allows for us to kind of more easily, sorry, there's something going on with my throat today, more easily solve this weird kind of reading-writing issue. So that's the reason why we're using shared memory for that. For this, also the reason why we have some weird serialization issues. So now let's start talking about different, more unique solutions to this. So there's one really cool solution to the serialization issue, which is to say that we essentially tag each entry with the very last thread that actually wrote to that value. So for example, if you had two people trying to write to 0 at the same time, you would have two different threads both writing, and the one that wrote to it last would then be tagged, so it can't write to it again, and you basically do the writing process again and again and again until basically all the threads are done. This allows for you to kind of mimic the serialization. Another way, again, is to create multiple shared memory tiles, 1, 2, 3, 4, 5, or something like this, a bunch of different shared memory tiles, so that if things do happen to collide, you can just, kind of say, okay, well, they're not actually colliding. They're writing to their own separate location in memory, and you're creating like a sparse shared memory tile that's 2D instead of 1D. There's a bunch of other things here. You better show me the histogram, or I call clickbait. Whoa, 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 whoa. Like, we're getting there. Give me a second. We're slowly but surely getting there. We're actually talking about why histograms are so cool right now. So, thanks for coming in. But we're going to get there in a second. So what else was I going to say here? Okay, so here's where things start getting really cool, right? So we've talked about two different ways that we can solve this parallel histogramming problem, but actually, in fact, there are a huge number of ways that we can solve this problem that, I hadn't even considered before. One clear way is via sorting, right? So what you can do is if you have a list of numbers, right? This list of numbers up here, well, if you sort them already, then you'll get a list that's like 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 7, 7, 8, 8, or something like this, right? And so if you can create a sorted array, you basically have a histogram for free. And the opposite is true as well. I think is the sort called bin sort? I feel like heap sort. Bin sort? What is it called? What is that sorting algorithm called? I can't remember. It is called bin sort. Bucket sort. Bucket sort's what it's called. How could I not remember bucket sort? It's similar to a bucket sort type of way. So if you can create a histogram, you can then also create a sorted array. And so essentially one way of solving the histogram problem is to first sort the data, and then after sorting the data, you can do a more coalesced read and write. However, if histogramming is giving us a problem, sorting is definitely going to give us an issue. So this, method, though potentially, valid, will probably also be slow on the GPU. So what is another thing that we could do? Well, one interesting thing that I read, very recently, was the use of, what's it called? Multi, crap, what is it called? It's multi-sort? Oh, wait. I have it printed out. I just printed it out like earlier today, and where did I put it? Okay, give me a second. If you guys need to, put your sunglasses on. I use Discord light mode. You guys are going to have to deal with it. Okay, it's in the paper pile, and I don't remember which one it is, but I think it is this one. Must be this one, right? Copy link. Multi-split. That's what it's called. Multi-split. Oh, I suck so much at remembering things. Okay, multi-split. What does this one do? So this is an actual interesting, not multi-pass. This one's actually an interesting method where instead of splitting things up into a perfectly sorted array, what you can do is you can split them up into a semi-sorted array. So for example, you can say everything under 5, if n is less than 5 on one side, and then if n is greater than or equal to 5 on the other side. And so in this way, what you can do is you can create like a kind of, not a true sort of everything, but kind of like, create larger bins to throw things in and then kind of sort those bins smaller from there. And so this is a way for us to, there's a way for us to modify the multi-split algorithm so that we can use this actually to find histograms as well. And the reason I want to talk about histograms so much is I feel like there is actually something new about using multi-split specifically to create a fast histogram on the GPU that has never been done before, and I'm really excited about it. That's what I'm super excited about. I actually switched to light mode on Discord to support light mode users. That's fair. But yeah, I'm actually quite interested in getting into this kind of stuff because like, quite frankly, this is actually the stuff that I really like. Doing this kind of stuff. Wait, what are you doubting, Galabunga? You're doubting that there's something new here? I'm not saying that it's going to be like the fastest, fastest histogram method ever on the GPU. That's not what I'm saying. But what I am saying is, I think it's quite useful. Trust radix bin sorting was about as fast as memory can go. Thrust radix bin sorting was about as fast as memory can go. Is that true? Oh, yeah, that's probably true. Yeah, that's probably true. I mean, like, I would like to compete with that. Yeah, Thrust is the C++ library used for NVIDIA CUDA. Yeah, I know what Thrust is. I'm pretty sure you're right, but the difference here is that I'm not trying to solve sorting. I'm trying to solve histogramming, right? And so, like I said before, going from a sorted array to a histogram is still kind of not exactly trivial. And so I'm not trying to like solve the sorting issue. I've got a feeling that other people have like way better sorting methods than anything I could come up with. But binning methods are something that I don't see many people talking about, even though they're kind of similar. Like I said before, it's a very similar way to think about it. It's not exactly the same problem, right? And again, they're quite similar, but I do think there's something new here. Anyway, it's just something I hadn't seen people do, and it's something I wanted to try. At the very least, creating a fast histogram method for the GPU would be quite nice. I got some memory about a paper from 2014 by Gunrock or something like that. Yeah, if you could link that in chat, I'd be happy to read that. Because I've been looking this up, quite a lot over the past few weeks. And I'm just, I just want to see where things go, But yeah, I don't know. Can we use, I actually have not looked into this because I used Thrust so little when I used C++ because basically you just had to, put everything in. But let me actually see Thrust in Julia. I don't think you can use Thrust in Julia. For sorting. Yep. Okay. Thrust is a C++ library that heavily relies on templates. Wrapping isn't straightforward right now. We basically need a C API, and I don't know of libraries like that. There's this one. Right, exactly. In my opinion, only a small subset of Thrust needs to be wrapped. Writing a short C++ code to make a C-style interface like in Thrust RTC sounds good enough for me. What do you think? I guess it's possible. We have a sort kernel now. Wait. I want to know what the sort kernel does. Where did the sort kernel come from? All right, let me take a look at the CUDA.jl source code and see where the sort kernel is actually. I'm going to pull this down and see what they have. Basically, I want to see how optimized it is what I want to see. So let's grab this and see what we got here. Sort kernel is awful. That's what I've got the feeling. I've got the feeling that we might be able to at least improve that. Okay, so let's do. We should probably also benchmark it with Thrust as well. Is what we should do. Now, doing that benchmark is going to be non-trivial. I think maybe. Okay, we should do the benchmark and see actually how much slower it is. I'm not saying we do that today. I just want to kind of take a look at what we got. See, back a couple directories, git clone this guy. Yes. Oh, I already have it. Okay, git job log. Cool. Let's do git pull. Alright, so git remote v. And let's do git pull origin master. They might have changed it to main, I don't remember. Okay, good. So there should be a sort kernel then. I guess if I just do grep-rl sort, I can probably find it. Looks like sorting.jl has it. So it's going to vi test sorting.jl just to see what we have. Sort. Sure. So now let's go into vi source and sorting.jl. Okay. If I recall correctly, it was an in-place merge sort with odd even for tail. Yeah, let's see what it is. The main quicksort kernel uses dynamic parallelism. Let's call block size M. I wish. Okay. We've got quicksort, cumulative sum, right, batch partition, partition batches kernel, batch consolidation, function consolidate batch partition, sorting, bubble sort. Why do we have bubble sort? Quicksort kernel. I don't know if I want to dig into this, but okay, so what we know is that this is not a wrapper on Thrust, right? Now, I'm not going to sit here and say that Thrust is necessarily the fastest, but what I will say is that chances are it's pretty optimal considering that it was written by, I think it was written by NVIDIA developers, right? I don't think bubble sort is quite good. I don't think bubble sort is quite good on the GPU as it may be on the CPU. I don't think bubble sort is good at all on the GPU. I think it's quite bad because I mean what you're doing is you're going through the array and you're like swapping elements, right? The act of going through the array iteratively is already bad. But you won't be going iteratively. Wait. There might actually be a parallel bubble sort might not actually be so bad. Actually, maybe it's not so bad at all. We should not use worse sort. Wait, let me think about it actually. So bubble sort on the GPU, you're going to go through each individual element. There might be a way to make it fast. But what I'm saying is, journal new page before. So what I would probably consider doing if I was doing bubble sort on the GPU, you have the list, here's your list of numbers or whatever that you're trying to sort. And usually you just go through and you switch any elements. So like, for example, this 4 and 3 would be switched because you want to switch it so that the greatest number is on the left. So you could potentially go through and you could create a coalesced array on the shared memory that's, basically 4, 1, 9, 0, basically all the odd numbers, and then do the swap. There's a way to make it fast. Like, I'm not saying that this is It's not good, but I'm saying that there's ways to optimize it to make it not bad. I think it's something to think about, definitely. Because if you pull onto shared memory, basically all the odd numbers and all the even ones in like two separate shared memory arrays, essentially, you could basically create a list. You could then create a list of all numbers that you need to swap and all numbers you don't need to swap. And then from there, you could. Okay, it's something to think about. I'm not saying this isn't the point of today's stream, but the point is you could kind of, fiddle some bits around and you can make it not bad, is what I'm trying to say. But its default implementation is certainly not good. Let's see. I do want to benchmark this though, actually. Let me see what they did for bubble sort, actually. This is CUDA.jl, so they don't really care about CPU stuff at all here. It should specifically be GPU engineering here. I would suspect, let's see, at inbounds begin, L is minimum block dimension X. Then we do, let's see, sync threads for L level in L. We do buddy. What are they doing? So they must go through a bunch of different levels. So how do they get the level? So the level here is going to be the minimum of block dimension in L, where L is read in. So I don't know what L actually is. Okay, whatever. I'm thinking too much about this. Like, who cares? Just as a matter of fact, have you heard about the notion of obliviousness in complexity? I have not. Maybe I should. What is that? Yeah, maybe I should know more about this, but I don't. Oblivious two-way finite automata. I always have trouble pronouncing that word. Yeah, could you give me a link to explain what that is? Also a link to that paper that you were talking about. But yeah, anyway, so I did want to go through and just kind of mess around with histogramming methods is what I wanted to do. As a characterization of an algorithm which says that the algorithm is optimal whatever the parameters are. Oh, yeah, fair. That makes sense. I'd like if someone said the algorithm is oblivious, I'd probably be like, yeah, okay. I'd guess that's what it would mean, probably. Yeah, that's fair. Okay. So, right. You have a good point here. I have not done enough CUDA stuff at all on this computer. As in, I haven't done very much specifically C++ CUDA stuff. So because of that, I think kind of pulling in the thrust library and doing some benchmarks on that would actually be, I think, quite useful. Now, the thing is, the benchmarking suite with C++ is not as robust as it is with Julia. So, like, because we're doing different languages, I think it might be a bit difficult to work with. Let's see. Also, Ignazio de Murge, thank you so much for that. And I think this is actually the exact paper I was looking at. Yeah, I think this is exactly the one that I have been. Oh, that's not going to work, is it? Oh, this is it. Yeah, no, this is the paper I've been reading recently. I actually have it printed out upstairs. And these are the ones that I'm following, actually. Can I download the PDF? Will it let me? Maybe. Yeah, this is actually the exact paper, or one of the papers that I've been looking at to do this kind of stuff with. The one, gosh, I cannot speak today. Okay. On something free on Springer? Right, I was also kind of surprised. Let me go over here. So the other one that I was looking at is copy link. This one, which I think is, I don't know if it's older or younger. This one here is efficient histogram algorithms for NVIDIA CUDA capable devices. Here. Daily limit exceeded. You have exceeded your daily download allowance. Have I now? Okay, well, I just wanted. Okay, so this one's from 2007. Right, right, perfect. So I was going to implement these, the ones from 2007 to start, because I just kind of wanted to open the ones from 2007 to start, just to kind of get our feet wet, you know? And then I kind of wanted to go through and just kind of implement all of the different methods, you know, not all of them, but all of the important ones, all the ones that are like boundary pushing, you know? In doing that, I saw a few, like, for example, the multi-split methods and stuff like that, which only came out like a few years ago. And I wanted to see how those compared. Basically, I just wanted to see how all the different methods compared. That's what I wanted to do. And I was hoping to create maybe a package in Julia that kind of wraps them all together, maybe called like fastbin.jl or something like that, with the clear purpose of just kind of, you know, obviously creating a fast binning implementation in Julia is one thing. But, you know, the other thing would be just going through and just learning more about the histogramming methods and stuff. Now, is this actually like going to make interesting video content? Like, I'm almost positive it's not. Like, I mean, if I'm honest, people don't care about this type of stuff, but I think it's quite cool, and I don't know, it's stuff that I've always wanted to tackle. And I think it's time to just look into it, you know, see what we can do. Okay, so we're going to Control D, and over here we're going to CD into projects, histograms. Anyway, right now we're super far from that. Super far from that goal. In fact, like I said before, I'm not convinced that we're going to be able to do anything that's going to be faster than like other people's libraries that already exist. But those libraries are not currently in Julia, so at the very least, we're doing, you know, something new here in that we're porting things over to Julia where they might not have been before. So it's at least useful for someone. It's at least useful for our future projects, you know, with fractal compression and stuff like that. Okay, and it also helps, you know, debug kernel abstractions and stuff like that. Okay, Gawabunga, you seem kind of... Okay, what are you saying? I'd rather prefer a wrapper over the thrust or hip. Yeah, I mean, I'd rather not do that, though. I mean, actually, I don't think I've looked at hip before. Yeah, I don't know hip at all, actually. Oh, hip is for... That's why, it's for RCM. Right, okay, that explains it. Yeah, I mean, look, it's... Yeah, I don't know. Yeah, I don't know. I want to just try it is what I want to do, you know? Because, I mean, having a native Julia implementation, I mean, you're right that having a wrapper over this stuff is probably just as good. I know there's no problem with that, but also, like, it's just such a mess, you know? Like, you're going to have to basically, I mean, like Tim said in the issue there, it's a huge mess to wrap like heavily templated C++ code. I don't know, maybe HIP isn't that way, but having a native Julia implementation is kind of nice. Reminds me of my repository, GSTL. What is GSTL? Here, paste there. STL, this purpose was defined. Wait, this library was designated as a complement to CUB. It aims to provide similar functionality to the STL while including notions of parallelism. It therefore focuses exclusively on block or warp operations done in order to serve as primitives for your program. Right. Okay, so what does this do though? Okay, so maybe I don't know what STL is. What is STL? That's not what it is. File format? No, that's probably not what it is either. STL is the C++ library. Right, but what is STL? STL C++? I've forgotten everything about C++. Standard template library. Ah, right. Okay, maybe this is because I really hate templates in C++, so I tried to avoid them whenever I could, because I genuinely hate them. Unless I'm misunderstanding what this is. Standard template library. Let me see if I have any. It's all basic algorithms that you need. It could be. I honestly don't remember. It's been such a long time since I used C++. I probably just included STL if I needed it. Standard template library, tutorial. I got it. It's just been so long since I've done C++. I don't remember any of it. If I do, I'm just gonna look at old code and probably like kind of work from there. I do like using C++ every now and again, but it's been a long time. Oh yeah, I never did any of this. I always implemented my own. I mean, except for vector, but vector was std, not stl. Yeah, I never used any of those. I never used sort, transform, any of those. They weren't particularly useful. The only thing I used maybe was a priority queue when doing Huffman encoding. That might have been the only thing I've used before. But even then, I usually kind of implemented my own for most of the stuff when I did it. It's not saying that I probably should have been using the STL library. It's just that it was easier not to worry about dependencies at the time, which is a big difference between my C++ coding and my, like Julia coding and stuff. Hey, Cobalt, how are you? You added a middle name since the last time I saw you. I don't know how long ago that was done, but hey, nice middle name, I guess. Okay. Right, so what I'm going to do next, I don't know what oh yeah, the middle name, right. Okay. Let me do an ls here, and let me just go into vi histogram.jl, and let's just kind of mess around with what we have here. So the first thing I'm going to do is remove this if statement because we actually don't need it anymore, and see if the code will at least run on the CPU. Okay, so for x, here and there, right. Okay, so let's go ahead and write this. And now we're going to go back over here and we're just going to run Julia. And let's just do include histograms.jl and just run it really quick just to make sure it runs. Just to make sure it runs. Why is everything black and white here? I just like black and white. It's my preferred theme. Besides, it's not all black and white. There's a little blue strip up here. My face is a different color, and also there's a little green over here. I mean, it is what it is. Okay. So we have histograms.jl. Let's go ahead and create some sort of input value, and then what we're going to do is we're just going to run it really quick. So let me just run histogram kout, histogram tag, and just to make sure it runs and we get something out. Perfect. Too many colors, right. Okay, I actually am going to close stream here, guys. I'm so sorry. I'll be back tomorrow, but I'm going to close it here. I just got a notification that I've got to attend to. Sorry, it was kind of a failure of a stream, but I'll be back tomorrow, hopefully for a longer stream, and we'll go from there. Anyway, guys, thanks again, and I'll see you next time. Sorry about that.